Hello. In this video, we're going to be discussing matrices. Now, a matrix is a set of numbers put into a rectangle. So a matrix has dimensions that are listed with rows by columns. A matrix with m rows and n columns is written with dimensions of m by n. So the x there just is read as by, so it is m by n as the dimensions for a matrix. Now I have an example over here to the right. You can see that all these elements are A with a certain number of subscript, and they're written in their positions, like A sub 1 1 is in first row, first column. A sub 1 2 is in first row, second column, and so on. Now, we're going to perform operations on these matrices. So to add or subtract, first of all, the matrices have to be the same dimensions. And then in order to do this, we would just match the positions of each element, then just do either the addition or subtraction. So we want to find the elements in the first row and first column in both, and then do add or subtract, then the first row, second column, and so on. So let's go ahead and look at number 1 here. First of all, do they have the same dimensions? Now, this first matrix has 2 rows, and you can see it. There's 1, there's 2, and then 2 columns. Here's 1, here's 2. So this would be a 2 by 2 matrix. Same with the other one. It has 1, 2 rows, 1, 2 columns, also 2 by 2. So these would be the same dimension. So let's go ahead and do the addition. To do this, we need to find the elements in the same position, then add them together. So the 3 from the first matrix is in the first row, first column, and the second matrix's first row, first column is a 6. We'll add those together. The 5 is first row, second column, and then the -2 from the other matrix. From the first, -1 is in the second row, first column, and so is -9. And then in the second row, second column are 4 and 7. And these get added together, and 3 plus 6 makes 9, 5 minus 2 makes 3, -1 plus -9 makes -10, 4 plus 7 makes 11. And there is our matrix after addition. Now in number 2, something different's going on here. Notice that these are a different shape. The left matrix has 1, 2 rows, and then 1, 2, 3 columns. This would be a 2 by 3 matrix, whereas this is still a 2 by 2 matrix. So since they have different dimensions, the subtraction we were being asked to do here, this is not possible. And you can see why in the first one we had to match up elements, but the left matrix has a first row, third column, and second row, third column, while the second matrix doesn't have that, so it has nothing to do the operation with, so there's no addition or subtraction possible here. We were asked to do subtraction, wasn't going to work. Let's try some other operations. On this page, we're going to talk about multiplying matrices by a scalar. And so to do that, when we say a scalar, that means we're just going to scale the matrix up or down depending on what we multiply it by. And we simply just take each element in the matrix multiplied by the scalar. For example, in number 3, we want to do 3 times matrix A. So we're going to take 3 and multiply it by all of 4, -6, 5, and 3. And so it's going to look like 3 times 4, then 3 times -6, and 3 times 5, and 3 times 3. And so then the calculations we come up with are 12, -18, 15, and 9 for the bottom row. And there's the matrix after being multiplied by 3. Now in number 4, we have 2 different scalars, and we're doing some subtraction between our matrices as well. Now we already know what 3a is. 3a we calculated above. That's going to be the top row 12, -18, and the bottom row 15, 9. Now we're subtracting that by when we take 2 times b. So we're subtracting 2 times all of the matrix B, which is -2, 9, -7, 1. And so we end up multiplying together, or excuse me, subtracting. We can do 12, -18, 15, and 9. And then we're going to subtract, and I'm going to distribute the -2 through to both things. That's going to get us a plus sign here when I take -2 times -2, -2 times 9, -2 times -7, and -2 times 1. And then we can actually do the addition now. 12 plus 4 makes 16. -18 plus -18 is -36. 15 plus 14 is 29. And 9 plus -2 is 7. And so that is the matrix when we do 3 times A minus 2 times B to name those matrices. All right, one more thing that we can do with matrices here. When we have two matrices and we want to multiply them together, now this is pretty unique. The number of columns from the left matrix has to be the same as the number of rows from the right matrix. If they're not, then we cannot do multiplication. We take each row from the left and then we multiply every element in that row by its corresponding element in the column of the rightmost matrix. So whatever comes first in the row gets multiplied by first in the column, then second in the row is second in the column, and so on. Matrix multiplication is not commutative. That means you cannot switch the order in which the multiplication occurs. That is, you can't do A times B and get the same result as when you do B times A. Let's go ahead and do an example here. So in number 5, we're asked to do A times B. Matrix A is a 3 by 2 matrix. Matrix B is 2 by 2. And so since the number of columns from the first and the number of rows from the second match, then we can do our multiplication. Now, to take A times B, we take the first row from A, and we're going to start by multiplying it by the first column from B. This will get our new matrix in the element in the first row, first column. So we're going to take 6, which comes first in the row, times -8, which comes first in the column from B. Then we'll add -7, which comes second in the row, and 0, which comes second in the column. Next, I'll stick with the first row, but now I'm going to go to the second column. So the 6 and the -7 are going to multiply by 2 and -9. So 6 comes first, 2 comes first, -7 comes second, -9 comes second. So that was the first row multiplied by the first column, then the first row with the second column. Now we're going to move to the second row, which means in my new matrix, I'm going to move to the second row. -1 and 4 are going to multiply by -8 and 0. So -1 and -8 come first, and then 4 and 0 come second. Then I'm going to take that same row, the -1 and 4, with the second column, the 2 and the -9. So -1 with 2, and 4 with -9. And then lastly, I'm in the third row. So 5 and 3 are going to multiply by both the first column and then the second column. So 5 comes first, negative 8 comes first, 3 comes second, 0 comes second. And then in the second column, 5 and 2 are both first, 3 and negative 9 are both second. And then we just do the evaluation here. 6 times negative 8 is negative 48. Negative 7 times 0 is 0. When we add that together, we get negative 48. In the second part, 6 times 2 is 12. Negative 7 and negative 9 make positive 63. 12 plus 63 is 75. Negative 1 and negative 8 make 8. 4 times 0 is 0. Adding those together, we just get 8. Negative 1 and 2 is negative 2. Plus negative 36, we get negative 38. Negative 40 plus 0 is negative 40. And then 10 plus negative 27 is negative 17. And there is the result after multiplying matrices A and B together. Let's look at one more. We want to do A times C now. Well, A is a 3 by 2 matrix. C is a 3 by 3 matrix. Now notice that the number of columns from the first and the number of rows from the second do not match. So if I were to try to take 6 with negative 2 and then add on negative 7 with 8, and then there's not a number here to multiply by the 10 in that last part there. So because those numbers don't match, the number of columns from the first and rows from the second, this multiplication is not possible. And there are your operations on matrices. We are done.